Hi everyone, welcome back. In this lesson, we are going to learn a very important feature, how to place and manage copper errors in EasyEDA. First, let's quickly understand what a copper error actually does. A copper error is basically a large piece of copper placed on your PCB. It's commonly used for ground planes, power planes, or signal shielding. This not only increases the current carrying capability, but also helps with heat dissipation and EMC performance. So, using copper properly is a key part of a good PCB design. Now, how do we actually place a copper error? It's very simple. From the top toolbar, click Place Copper Error. Once you're familiar with EasyEDA, you can also find its shortcut icon. It looks like a dashed rectangle in the toolbar. After that, your mouse will turn into a drawing tool. Just click around the workspace to define the error's boundary, and when you are done, a pop-up window will then appear, letting you configure your copper error settings. You'll see several options in the Properties panel. Type by default is set to copper error border. Name, you can assign different names to different copper errors. Layer, choose top layer, bottom layer, or if you are working on multi-layer board, any of the internal layers. Keep in mind, if a layer is defined as an inner power plane, you can draw a copper error on it manually. Among all these settings, the most important one is net. You need to assign the copper error to network, such as GND or VCC. Only then will it connect to the rest of the circuit. If you leave it unassigned, it becomes an isolated copper patch. It looks fine, but it's electrically useless. So always double-check your net setting. Next, let's go over a few other useful options. Lock fixed position of your copper error so it can't be moved or resized accidentally. Fill style, solid, normal copper fill. Grid 45 degree grid fill. Grid 90 degrees, 90 degree grid fill. Keep islands. Decide whether or not to remove dead copper. If a small selection of copper isn't connected to any network, it's treated as dead copper and removed. Optimization, available only in solid fill mode, is enabled by default and automatically removes sharp corners or thin traces more than 8 mm, which help improve manufacturing quality. You can disable it if you prefer to keep all fine details visible. Another very important setting is the net rule. Click the small gear icon next to it, and you can adjust clearance between copper and other conductors. If the clearance is too small, you risk short circuits. If it's too large, you waste valuable board space. Usually, keeping it as the default value or following your DRC rules is perfectly fine. Once you are finished configuring everything, click Confirm, and the software will automatically generate your copper error. For a typical two-layer board, you usually create copper errors on both the top and bottom layers. Just switch layers and repeat the same steps. One thing to note, copper errors don't automatically update when you move parts or reroute traces. So after any layout change, make sure to hit Rebuild Copper Area on the right toolbar. This will recalculate the shape and ensure all copper zones are properly connected to their nets. If your copper doesn't appear, looks broken up, or still show floating islands, try adjusting the layer visibility, clearance values, or toggling the Remove Island option. If you are still unsure, you can also check the previous chapters for a more detailed explanation. Let's quickly summarize what we learned today. To place a copper area, go to Place, Copper Area, draw the boundary, set your net layer, fill style, and net rule. Then click Confirm to generate it. Once you got the hang of it, your PCB will look cleaner, more professional, and perform better electrically. That's all for this lesson. In the next one, we'll look at common copper area issues and some advanced optimization techniques. Thanks for watching, and I'll see you next time.